So guys, welcome to the lecture 13 part 1 and topic is sorting. So first we discuss what is sorting. So sorting is a process of arranging element in the particular order, either it is ascending or either it can be descending order based on the certain criteria. Example, you can see this is the input. So we just sort it. So this is a ascending order. You can see. So this is the sorted. So why sorted is important? So this is the help in. So sorting is a basically help in searching efficiently, like binary search used in the optimization problems, that is scheduling, basic for many algorithm like merge sort, quick sort and heap sort. Now we discuss the types of sorting based on the algorithm. So first one is a bubble sort. So basically in the bubble sort, basically we compare adjacent element and swap if they are in the wrong order. And time complexity for the bubble sort is a big of n square, and space complexity for the bubble sort is a big of 1, that is constant time, that is constant space complexity. And this is a stable algorithm. Now come to the second one, and second is a selection sort. So basically find the minimum element and places it at the beginning. And time complexity for the selection sort also take a big of n square, and space complexity also take big of 1. And this is a not stable algorithm. Now come to the third one, and third one is a insertion sort. So insert each element into its correct position in a sorted part. Time complexity for the insertion sort take big of n square, and space complexity take big of 1. And this is the stable algorithm. Now come to the fourth one, and fourth one is a merge sort. So basically merge sort is basically work on the divide and conquer technique. So basically divide array into the two half, then sort and then the merge. Time complexity for the merge sort take big of n log n. And this is the and space complexity of merge sort take big of n, and this is the stable algorithm. Now come to the fifth one, and fifth one is a quick sort. So this is also use divide and conquer technique. In this quick sort, basically we pick a pivot element and partition element. So basically in the quick sort, basically we pick a pivot and partition array, and time complexity for the best case take n log n, and worst case take big of n square, and space complexity for the quick sort take log n. And this is a not a stable algorithm. Now come to the last one, and last one is a heap sort. Basically we uses binary heap, that is max heap, or either it can be a min heap. So time complexity for the heap sort is a big of n log n, and space complexity is a big of 1, and this is a not stable algorithm. So now come to the type based on order. So ascending means smaller to the larger value, and descending order means larger to the smaller value. You can see the example of ascending order and the descending order. Now come to the we have STL direct function for the sorting. This is a basically ready-made function. So you can see we just use this sort function and just put array name. This suppose array name is a ARR, and we just write begin and just write end. So this is a basically used for the sorting for the ascending order, and you can see this is the basically used for the descending order. You can see. So now come to the key properties of sorting algorithm. So for the time complexity, for the space complexity, for the stability, stable sorting keeps equal element in the same order, and in place or not, use extra space or not. So this is a key point of the sorting algorithm. I think this one is clear to you. Thank you.